So I'm going to start my video for February 5th, Wednesday, and the title of the video is Finding Derivatives for a General Function. Okay, now what do you mean by that? Now, on the class on Tuesday, we actually learned what a derivative is. So, what is a derivative? So, if you take a function, say x squared, the derivative is nothing but, so if this is a function, if you want to find the derivative at a certain point, say 2, then you must draw the tangent at that point. The derivative is nothing but the slope of the tangent. Okay, so and we also learn how to find it for one example, which was to find it for the derivative of x squared at x equals 2. And if you go back to how we did that, but we did that, so we need to find the slope of the tangent at x equals 2. But then how do we do that? We take a nearby point and we take the point on the curve for that point. So this is the nearby point, and we looked at the secant and we took the slope of the secant, right? And then we actually set the limit of the slope of the secant as this point moves towards this point. In other words, when this goes towards this, in other words, this little difference h, when h goes to 0. So what we did was we used the formula y2 minus y1 over x2 minus x1 to find the slope of this secant, right? And then that turned out to be, if you remember, when we used that, it turned out to be this one. And so we wanted to find the limit of this so what we wanted was actually to find the limit of this as the limit as of this as h tends to 0, right? So we want to find the limit of this as this is a secant slope. We wanted to bring this point to here. In other words, we wanted to take this gap h going to 0. Then we found out that because this is a rational function, and when you take x going to 0, really the denominator becomes 0. So then we factored the numerator, right? And then we got the answer as 4. Right? That was the last thing that we did, that the h's got cancelled out. Now let's try to see whether we can do it for a general function. Okay, so that was for x squared. But now let's take a general function. So now we are dealing with any old function, the blue curve, okay, not just x squared. All right, so we call this function f, and we want to find the derivative at the point x sub 0. Okay, so once again, what's the derivative of x sub 0? You go up to the curve, you draw a tangent, okay, and you have to find the slope of the tangent. So but this is a limit of what? So what you do is we take a nearby point, and we always, if the x sub 0 is the point that we want, we go a little distance h, shift h, and we get the point x sub 0 plus h. Okay, and then we go up to the curve to meet that point. Okay, and then that's the point, the nearby point, and we find, can you see this secant line? Okay, so this is a point that we want, this is a nearby point. We look at the secant line and we want to find the slope of that secant line. So how do you find the slope of the secant line? Once again, we use the formula y2 minus y1 and divided by x2 minus x1. So what are these points? So x1, of course, is the point that we want, x sub 0. What is y1? Well, our function is f, right? So we plug in x sub 0 and then we would get y1, right? Because this right here will be y1, this distance, right? Okay, this will be y1. Okay, and that y1 we will get by plug in x sub 0. So this is actually y1. Okay, x sub 0. Okay, f of x sub 0. Okay, and this of course is x1. Then what is x2 and y2? Well, the second point is out here. So x2 will be the x coordinate of that point, and which is actually this one right here. And how do you find the y2? Okay, so this is x2. So sorry for the interruption. So once again, we are trying to find the slope of the secant line. In order to do that, we need to write y2 minus y1 divided by x2 minus x1. And of course, x1 is the point that we want, the x value of the point that we want, x of 0. And x2 is the nearby point. So this gap is actually h. All right, so this is h. And then x2 is the second point, this one right here. So x2 will be x0 plus h. And how do you find y0, y2? What you do is you go to this point, the nearby point. If the x coordinate is x0 plus h, then how do you find the y coordinate? You just plug that in the function. So f is a function, so when you plug in x0 plus h, you get this, which is actually our y2. Alright, so now that we have x1 and we have y1 right here, and we have x2 and then we have y2, we can now plug them in this formula, y2 minus y1 over x2 minus x1. So let's plug them in. So what is y2? F of x0 plus h, f of x0 plus h, minus what is y1? y1 is f of x0 divided by x2 minus x1. So what is x2 minus x1? So this is x2, this is x1. So the difference between these two is this gap, and the gap is actually h. So x2 minus x1 is actually h. You can also see it in a different way. When you subtract this from that, then the x of 0 get cancelled off and you get h. Okay, so finally we have this right here to be the slope of the secant. So this is the slope of the secant line, PQ. Alright, okay. So then how do you find the slope of the tangent? So the slope of the tangent is the limit of the slope of the secant line. So you take the slope of the secant line, which is this, and you take the limit as h tends to 0. So now remember this formula very well. This is the slope of the tangent to the function at the point x of 0. So in other words, if this is the slope of the tangent, then this is the derivative. So now we can finally define the derivative of a function, of any function, because f is any function at a point x 0. At this point is given by f of x0 plus h minus f of x0 over h, and the limit as h tends to 0. Okay, so now this is the derivative at any point x of 0. So in particular, if you want to find, say, at a certain point, say at 5, x equals 5, suppose you want to find the derivative at x equals 5, then all you do is go up here, and for x of 0 you plug in 5 and you get what? F of 5 plus h minus f of 5 over h. If you want it at, say, 8, then it will become f of h plus 8 minus f of 8 over h. So let's take an example, because without doing an example it's kind of difficult to understand how to do this. Okay, so now here is an example. Find the derivative of the function f of x equals x squared plus 1 at the point x equals 3. Now previously we looked at just x squared, but now we are looking at x squared plus 1 at the point x equals 3. So even without the graph, you can just find the derivatives. According to this definition, how do you find the derivative? You go up here and first of all, you got to identify what x of 0 is, because they want to find at 5. Okay, you come up here and you plug in 5 for x of 0. So then what will we get? We will get f of 5 plus h minus f of, again, 5 over h. Okay, so that's the first line. The derivative is equal to f of 5 plus h minus f of 5 over h. F of 5 plus h minus f of 5 over h. Okay, sorry, f of, but then, yeah, I'm sorry, we want it at 3, right? So if it has 3, then what we put is we put f of 3 plus h minus f of 3 over h. Once again, we want it as S3, so we put 3 plus h minus f of 3 over h. Okay, now let's try to find this. Now the next thing to do is to find these things and calculate this limit. Okay. All right. So first of all, what is f of 3 plus h? Okay. Now f of x is what? X squared plus 1. So if f of x is x squared plus 1, okay, then how do you find f of 3 plus h? All right. What you do is you go up to f of x and replace the x here by 3 plus h. Then you get f of 3 plus h. But this will also get replaced by 3 plus h. And if there are any other x's, this will get replaced, but this is the only x here, so only this x will get replaced by 3 plus h. So what do we get? 3 plus h quantity squared plus 1. So we get 3 plus h quantity squared plus 1. So at this point, it might be a good idea, you don't have to do that, to expand it out so that it becomes simple. So we have a complete square here. So we expand it out, what happens? First of all, you get 3 squared. So you get 3 squared plus twice the middle term. So you get 2 times 3 times h, which is what? 6h, plus you get the second one squared, which is h squared. And then, okay, so 3 squared plus twice the middle term 6h plus h squared plus 1. So 3 squared plus 1 is 10, because 3 squared is 9. 9 plus 1 is 10. So you get 10 plus 6h plus h squared. Okay, so that is f of 3 plus h. Okay, so this is now that. So this is actually equal to 10 plus 6h plus h squared. Okay. What about f of 3? That's pretty easy actually. What you do is you replace the x by just 3. So you go to your function right here and replace the x by 3. So we replace the x by 3, what do you get? You get 3 squared plus 1. Right, okay, you get 3 squared plus 1, and that is 10. So this right here is 10. And what was this now again? 3 f of 3 plus h was what? 10 plus, right here, 6h plus h squared, right? So 10 plus h plus h squared, right? So 10 plus 6h plus h squared minus 10 divided by h. All right, so now plug everything back in. So 10 plus 6h plus h squared at minus 10 and then divided by h, and we want to take the limit as h tends to 0. So you can see that the 10 will now cancel out. Okay, and then you will end up with 6x plus h squared over h. Oh, you know that this is a rational function, right? All right, so how do you find the limit? You just plug in the part, you go to the bottom, the denominator, and check. Well, not good news, because the denominator becomes 0, right? Then what do? You factor it, right? So if you factor it, you can take out an h from outside, right? From this, right? So you get, let me write it slowly. So you get h times. So if you take the h out from this, you get 6. Plus if you take the h out from this, you get 6 plus h, and then you have a h at the bottom. And then what will happen is this h will cancel off with this h. and then you have 6 plus h. Now that's a polynomial, so now you can plug in h equals 0 and you get the answer as 6. Alright, so now I've got the answer at 6. So what does that say? The function that we started off was x squared plus 1, right? Okay, our challenge was to find the derivative of the function f of x equals x squared plus 1 at the point 3. So once again we use the definition because we want it at 3. It's what? We plug in, the first thing we did was we went to the definition and we plugged in 3 here. So 3 here, 3 here, and then so we wrote it as f of 3 plus h minus 3, and then we went to the function and we calculated each one of these. We first found f of 3 plus h, which was this, right? And then we found f of 3 by putting 3 into the original function. Okay, and we got 10 there, and then we took this junk and this and plug it up here and divided by h, but because the denominator goes to 0 we need to factor this, right? And then we factor that and we got this one, and the h's cancelled off and you got 6. So this is the derivative. This is the derivative. Right, so I guess I could type faster than I can. So so this is the derivative. So if you want to do it, right, you can say, what can you say? The derivative of the function f of x plus 1 at x equals 3 is equal to 6. This is the derivative. Alright.